Welcome back. Let's find out how you did. You were asked to graph y equals 1 plus tangent x. So if I draw a quick sketch of tangent x first, we know that tangent x has an asymptote at pi over 2. We know it has one at negative pi over 2. We also know that it passes through 0, and I'm going to do a dashed line since this is not the final curve. Continuing out in this direction, we know this is pi, and our next asymptote happens at 3 pi over 2. And again, dashed line. So that's our tangent curve. And what we want to do now is recognize that this is a horizontal shift upwards of 1 unit. So I take each of these points and literally put them up 1 unit higher. So my curve it looks like this. And over here, I'll just sketch it approximately looking like this. So you can see, compared to the dashed line, clearly it's been raised up 1 unit. Of course, as we get further and further up, it's not as clear or as easy to see. Well, I hope that's the graph that you were able to find when you did it. Let's verify that graph on the calculator. So pushing our equation button, we can put in tangent x and 1 plus tangent x, and then graph them on the same coordinate axis. So there's tangent x, and there you see y equals 1 plus tangent x, which shows that it's been shifted up by 1 unit. All right then, we will complete this section with graphing of a cotangent function that involves vertical and horizontal translations along with vertical and horizontal shrinking. Graph the function y equals -1 plus 1/2 cotangent of 2x minus 3 pi over a 2-period interval. Now, we need to manipulate this equation a little bit, but I'm going to actually graph this on the graphing calculator. But before I do that, let's go back to the graphics so that I could show you the manipulation that we need to do. In order for us to be able to figure out the period and phase shift, we need to factor this 2 from here. So my equation would become y equals -1 plus 1/2 of cotangent, and then what I would use is brackets, factoring out the 2, parentheses x minus 3 pi over 2. Close the parentheses, close the brackets. Because now we can clearly see that b is equal to 2, and my phase shift is equal to 3 pi over 2. So with b equaling 2, that means that the new period for this particular graph would be pi over b, pi over 2, so pi over 2, as opposed to the normal one for cotangent, which is pi. Let's go to the calculator and let's plug in the equation the way you need to, remembering that cotangent is the reciprocal of tangent. So in my equation editor, I need to clear out my tangent curve, and now I can type in -1, then my plus, and this time I would have 0.5 for my 1/2, and now I'm going to use parentheses just to make sure it's offset. That is, I want 1 over tangent, 1 divided by the tangent And when I plug it in here, I can leave it in the form 2x minus 3 pi, because the calculator will do the correct manipulation to that. So now when I press graph, we will get the tangent, and I want to talk a little bit about this with you. The asymptotes that you see are occurring at intervals of pi over 2. So right in the center, of course, is 0. The first asymptote to the right would be pi over 2. The second one would be pi. Moving to the left, it would be negative pi over 2 and then negative pi. Normally, you would expect the tangent to go through pi over 4, but this entire graph was shifted down 1 unit. And so you can see that instead of going through pi over 4 comma 0, it's going through pi over 4 comma negative 1. We covered a lot of material in that particular section. Great job following along. Now, skill comes with practice, and this is especially true when graphing the circular functions. It is important to understand the behavior patterns of these circular functions. So be sure to complete all the exercises that your teacher assigns, and we'll see you next time.